Welcome, everybody. This is our final session for the ASA Early Career Researcher Chapters How-To series. Today's topic is how to polish, publish, and cite code. This session is being recorded, and I will be your moderator today, so you can contact me if you have any issues. First, we'd like to begin with an acknowledgement of country. In the spirit of reconciliation, the ASA ECR chapter acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. The ASA is committed to making ASA organized, sponsored, or supported meetings, events, and publications inclusive, productive, and enjoyable for everybody, regardless of age, caring responsibilities, cultural diversity, disability, gender, ingenuity, sexual orientation, gender identity, physical appearance, or religion. So without further ado, we're going to go ahead and get started with today's session. Paul will be leading the way, Paul Hancock, with help from Nick Swainston as well. There is a chat box available if people have questions, or I'm sure this is a fairly informal event. If anyone really has pressing questions, you can raise your hand and we can have a chat. So with that, I will let Paul take it away.
Thank you, Nicole. All right, so I'll just share my screen. Okay. All right, so thank you very much. So this is the how to polish, publish, and cite your code. So Nick and I are from ADACS. So this is relying on some material that we've had before, which has all been hopefully quite nicely collated and collected together in one place for you to easily digest today. So Nicole has already covered the welcome to country, and I just wanted to extend that and acknowledge the Whadjuk people of the Noongar Nation, who are the traditional landowners here in Perth. Yeah, so my name is Paul. I know some of you, but not all of you. So welcome. And as Nicole said, if there are any questions, please feel free to interject, raise your hand, or chat in the chat box. We also have Nick here, who is going to be assisting. And I think we can skip the virtual etiquette. We've all done 1,000,001 Zoom meetings by now. I've got a link to a code of conduct here, but I think we will go with the one that Nicole nicely introduced. So the plan for today, which we may or may not stick to, is that we're going to spend the first half of this session talking about how to polish code. Then we're going to have a bit of a break in the middle for walking around and whatever. And then we'll spend the second half talking about how to publish your code and how to cite your code. Okay. This is meant to be as informative as possible. And so I really want you to interrupt me, ask as many questions as you can. The goal here is not so much for me to get through the content, but for you to learn as much as you can. We're going to be doing this in a partly interactive manner. So what I would like you to do is, if you could, in a browser tab or on your phone or something somewhere, go to the peardeck.com website, which should look like this down the bottom here. Click on join a session, and then up in the top right here, hopefully you can see this little 6-letter code. And if you enter that code, that means that you'll join this session. And initially, all you'll see is this set of slides that I'm presenting to you. But in a minute, we're going to get into some of the interactive parts of the presentation, and that's where you'll use your phone or web browser or whatever it is that you're joining to get interactive. So this little code here, this QZQLKT, this will remain here for the whole session, so you can come back and join that whenever you need to. I thought I had a little thing that told me how many people had joined already, but maybe it's disappeared. But if we go to the next part, so what I'm going to do, here we go. I can see there's 9 people who have joined up, which is great. So if you can enter your response out of A to E, which of these most closely represents why you're here today and what you hope to achieve? That would help me to understand what it is that you want. And well, in some ways, we're going to skip a bit of content or maybe spend more time on other bits of content, depending on what you respond. So you can see 6 people have responded. And if I press show responses, everybody should be able to see where we are. Unfortunately, not on Pear Deck, but at least on Zoom, you can see what everybody has been answering. And yes, this is all anonymous, so feel free to be completely honest. I'm glad nobody chose E because I don't have cookies to give to you, although I noticed that when I joined the Zoom session, it asked me questions about cookies. We'll see. We're not going to deal with those types of cookies. So, all right, a fair mix. I'm happy to see that there are some people who have selected D, because as much as I want to talk to the people who are writing software and want to publish or promote it, I think that we also need to engage with people who are not writing software, but want to understand how they can support people that are writing the software that they use. So for the people who have selected D, you've made me very happy. Okay, good. And I think more people are joining. All right, excellent. So we're going to start off by talking about polishing. And the very first question I have to you is, why do you want to polish your code in the first place? Okay, so this is not multiple choice. This is a free answer. So we've got 11 people now. You can see some responses. I think, yeah, I can scroll through these. So I'll give you a minute or two to answer this. Interestingly, it looks like it's live updating as people type. Okay. There's a lot here. Good. All right, so what I'm seeing are some very good reasons to want to polish code. So easier to fix bugs is very true. If your code is written in a well-structured, easy to understand way, it should make it easier to find problems when they occur and to be able to diagnose and solve those problems. Also easier to incorporate new features, easier for other people to use. So essentially this first one here is saying that polished code is code that's easier to develop. And it's what we would say reduces your future debt. So writing so a poorly written 5-minute script that you only run once, if it works and everything's fine. But if you're going to rely on that for a long time in the future, every time you run that bad piece of code and every time you have to come back to it, you have to invest more and more time into it. And so that's what we call the future debt. And so if you put some time into setting things up nicely in the first place, you can reduce that future debt. Making it easier for other people to modify. Yes, good. Others to use, others can understand it. Helps find bugs, good. Okay, excellent. So that I can understand it when I come back to it in a couple of weeks, months. So one of the things that that I like to think about is that when you're talking about other people using your code, you should consider you in the future to be a different person. Because, you know, apart from personal development and things like that, you often have forgotten what you did and how you did a particular thing. So another one of the ways that you can reduce that future debt is to make it easy for the code to understand, even for your own self. Okay, I'm sure we've probably had the experience where you look at something that you've done years ago, whether it was a paper that you've written or a report or a piece of code, and you look at it and you think, who did this? This is really weird. And then you realize that it was actually you. That's what we're talking about here. So, yep, making it so that you can understand it, more legible for others. Good, good, good. To improve uptake. Okay, that's another good one. So improving uptake. So if you're wanting your code to be shared with others, people are probably more willing to use your software or use your code if it looks polished, if it looks a bit more professional. I think people would be much happier to use it. So, you know, if somebody says to you, I have an executable file which is living on a random GeoCities website, please install it, you would probably say, no, this is a terrible idea, I'm going to get viruses. Whereas if it's an app that's part of an app store and it's got like a verified download button and all that sort of stuff, you'd be much more willing to download and use that software. And so that's one way that you can sort of polish your code, polish your software, is by having it packaged in a way that it's easier for others to use and also gives them confidence that it's going to be useful. I wonder if I can get rid of this completely. Maybe not. All right. Cool, cool. All right. Great answers. I had put some suggestions here in case people were shy and didn't want to write anything. And I think maybe the first and last one here weren't quite touched on. Some people want to polish code just because they think it's the right thing to do. They want to make sure they're doing it right. And maybe the other reason is that you gain some personal satisfaction from knowing that you can do good work. So these are all good reasons for wanting to polish your code. So another question, how would you feel showing your code to a peer? So a peer being somebody that you work with, somebody, I guess, who's at your sort of similar level of career. And if I show responses, so for this one, you drag the little fish and you put it where you would, how you're feeling. So, okay, there's a couple people who are actually not feeling too bad about this. Many people are kind of at the, a bit of hesitation around the orange face there. Can I ask somebody who has this fish over here, the most confident fish, whether that is because you simply don't care what people think or because you tend to have what you consider to be very well published code?
Yeah, that's me, Paul.
Oh, that's Nick. Okay. Oh,
So I hope my
out.
code is good enough to show people.
Okay, so Nick's saying that it's, yeah, he has some confidence in his code. All right, how about somebody from this little cluster of fish over here? What's giving you confidence to share code with your peers? Don't see, I can't see.
Well, so I'm happy to own up to being one of those who's sort of on the edge of the orange. It's partly a case of most of the code that I share with my peers is not too difficult. So it's not too difficult for me as a non-professional coder to get right.
Yep.
And it's partly also that I'm happy to share stuff that's not perfect because it also lowers that bar for perfection for other people as well.
Yeah, excellent. Okay, so I think that's they're really good reasons. I like those, and I think that's if you go onto GitHub and you just browse people's random repositories, you'll see that there are some people who are professional software developers. They'll have one or two repositories that are super well published, and they'll have a bunch of garbage on there. And when I say garbage, I mean just stuff that they haven't cared about. Okay, they've uploaded it, they haven't given it any love, and there's heaps and heaps of code like this on the internet, and it doesn't make you a bad person to share that code. And I like what Chris said about trying to lower the barrier to entry for other people and sort of like normalize sharing code and accepting the fact that you are not professional software developers. Expecting really high quality polished code from you is unreasonable. Your job is to do good research, okay? So we would expect high quality polished papers and publication outputs from you, but not necessarily software. Somebody from the orange group, one of these two fish, are you brave enough to let us know why you would be not that comfortable sharing your code with a peer?
Mine's just like pretty messy.
So embarrassment, is that what you're saying?
Yeah, probably. Yeah.
Okay, but have you been coding for a long time, or are you fairly new to writing software?
Yeah, fairly new. Yeah.
Okay, so I think that having messy code when you're new to software development is a very common thing, and so you shouldn't necessarily be embarrassed by that. I mean, obviously logic doesn't dictate your emotions, but yeah, many of us, well, everybody started somewhere. Okay, everybody started at some point, and everybody started writing not amazing code. So let's move on to the next one. Okay, I have 3 of these. I don't really want to do all of them. Here we go. Okay, so this is what I want to get to. So this is sort of 2 sides of the, well, I guess the same side of the coin expressed differently. So there's a tweet that I saw here, which I really love. And that is that the only way to write good code is to write tons of shitty code first. Feeling shame about bad code stops you from getting to the good code. Or if you want to go from, have a quote from Jake the dog, he says, dude, sucking at something is the first step towards being sort of good at something. And so in both of these cases here, we have this growth mindset where we say, in order to be good at something, firstly, you have to be bad at something, and then you work towards being good, okay? So just knowing where you are on that journey, knowing whether you're a beginner who has never written anything before, or somebody who's developed a lot of software projects, can sort of help you to, what's the word? I guess calibrate how good you think your code should be. Anyway, so that's all about why we would want to share code and how we feel about it. But let's get on to some of the things that we should consider about polishing. So there's many different things that polishing can mean, and I've chosen 5 things here that I think are probably going to be quite useful and tractable for people who are doing research. Okay. So the first of these is project structure. Now, my background is almost entirely in writing Python code. So if you are also writing Python code, you will, well, just about everything I say today will be great for you. But I'm not here to evangelize the benefits of Python. My own mentality, I guess, is the word mantra. That's what I wanted to say. My own mantra is that all programming languages are fine. They have their areas that they perform well and the areas that they perform poorly. And it's up to you to choose the right tool for the job. So I'm going to try and not be super Python centric. And so if you want to use C or R or Julia or Fortran or whatever other language is your choice, maybe even IDL, then these lessons should apply as well. So, all languages are essentially text files that you write, and then either a compiler or an interpreter will read through that, turn it into machine code, and the computer will run it. You should put some effort into thinking about where you're going to store all of these files. The way to do this is to think about a directory structure, a project structure. So I would suggest having a single directory, which is just for your software project. And then within that directory, split that into files that have different uses. So if you're going to write documentation, keep that in the docs folder. In Python, if you're writing a module, then you would have a my module sort of structure there. If you've got some bash scripts that either kind of help people use your code or act as entry points into your code, be good to keep those in the scripts directory. Hopefully you're writing tests, and if you are, keep them in the test directory. It's quite nice for a user if their first introduction to your code is a kind of a well-managed, a well-structured directory. And ideally the root directory has only a few files in them, so it's obvious for people to know where to start. And a README file, usually readme.md in Markdown format, is the first place that people will look. They might look at the license, probably not, but a README file or a file that just says installing is a great place to sort of draw people's attention and say, this is where you need to start. I'm going to explain to you either how to install the software or how to use the software, or at least how to find the instructions of how to use the software. So if you're using a compiled language like C or Fortran, you probably want to have like a build, a lib, and a bin directory to keep your lib for your library file, so the actual source code, a bin directory for keeping the compiled things, and a build directory for all those intermediate files. For interpreted languages like Python or R, you probably want to have a lib library or module directory, scripts directory, and maybe if you're using virtual environments, you might want to have an environment directory as well. So this is one way that you can structure your project, one way that you can polish your project, sorry. And this is something that you can apply this to existing projects, but depending on what assumptions you've made about where files and data are, this might require a fair bit of refactoring of your code to make it work properly again. But this is something that you can do quite easily next time you start a project. So don't feel like you have to polish every single piece of software that you've ever written. All of the lessons that we learned today can be applied to existing projects, but it's usually easier to just tell yourself, next time I start a project, I'm going to do one of these things. Maybe next time I'll think about the project structure and just get used to doing that. Okay. All right. The other thing about structure is not so much about the files, but more about the way that you provide all of the functionality of your software. And that is to think about having sort of two parts to your software. One is the library, which is sort of the core functionality of what your software is supposed to do. And you think about that as like the functions and the classes or routines or whatever your language has, is to put all of those in one file or one area in your library structure. And then you have this API, and an API is essentially just a way that people can interact with that library. And then you have a script, which is sort of like the front end. So the script is the way that people can access that library. So if the person who's using your software is just like an end user, they just want to, I don't know, calibrate some observations, or they want to, generate a simulation or something like that, they would just run the script. And that script then calls the library, it does all of the work, everything happens, and the end user is happy because things work. By separating this script from the library, it means that other people who are wanting to do development, either to modify your software or they're going to try and build upon it, maybe they want to incorporate your calibration scheme into their workflow, that can be really easily done if you provide all of that functionality as a library. So separating your code into sort of the script that runs things and the library, which actually does all of the work, can be quite useful. And again, think of others to include you in the future, or just you working on another project. Okay. So an example here, and this is where we're going to get a bit Python centric, is that we have this piece of code, which is just a really simple bit of code. It just generates array and deck positions at some location on the sky, and then it writes a file. And so what I've done here is I firstly created the library file. I don't know if you can see the name of the file. It's just called sim.py. And I've put this, there's this little, I don't know how to get rid of this box actually. Is there a hide video panel? No, that didn't work. Okay. Well, anyway, the name of the file is sim.py. And this is sitting in the SkySim directory. So in Python, this is how we create modules and submodules. And this file defines two functions, which is what I'm calling here the API. The two functions are generate positions and write file. If I ran this file, if I was to say Python 3 skysim/sim.py, it doesn't actually do anything. It just defines functions and then quits. Okay, so this is the library, and then we pair that with the script. So this is the script that's called sim catalog, and this script, all this does is imports those functions that we needed, the generate positions and write file, and then pairs that with this whole block of code here, which is essentially providing a command line interface, which we'll talk about in a little bit. So it's this script that calls the functions to make all of the work happen, to simulate the catalog. So when we call the sim catalog script, this actually does the work, okay? And by separating these two, it means that if I have another piece of software or another project that I'm developing, and I want to reuse that generate positions or write file function, I can easily just import that, okay? So that's another way that you can polish your code. It means that also the end user, if they come and have a look at the sim catalog, they're not bombarded with, you know, thousands and thousands of lines of code that they have to try and pick through to figure out what's going on. They just get this very simple interface here that just says, you know, we're going to parse your arguments and we're going to generate some positions, and then we're going to write the file. It's sort of very simple here. This is like the main function for this script. Alrighty. Any questions about the structure before we move on to the next part? So far, so good. Okay. So the next thing that you can do to polish your code is to provide a user interface. So don't always assume that your users are going to understand the language that you've written, or even the style of coding that you've chosen. So it's often a good idea to take all of the great work that you've done and then provide a user interface for people to interact with. The easiest one to do is a command line interface. Most people who are using software now have got used to using the command line. Even people who don't write software can at least use it from the command line. And particularly if your code is going to be run on a cluster or an HPC or supercomputer somewhere, most of these don't allow you to have a graphical user interface. And so you're going to have to fall back to a command line interface anyway. So a command line interface is easy and effective. It allows people to do things like script --help to understand how it is that I interact with this particular piece of code, to get those instructions. Now, for various languages, there are modules that have already been built to help you build these command line interfaces. So in Python, you would use argparse, and so that's what I'm using here. So this is me setting up argparse to accept different arguments for the sim catalog script that we were just doing. And you can see that there are default values for some of the arguments, for some of the options, there are default values. And there's also help here as well that lets people know what is expected and what formats they should use. This is all very similar to in C. You can use the get_opt module, I guess you still call them in C, and in R you could use optparse. These all work in very much the same way and will provide your users with a nice command line interface that they can interact with. So apart from help, what other useful things have you seen in a command line interface? Let's see. some responses. We're getting, every time we do this, we get more people joining, which is great. Okay, passing parameters, that's great. Okay, great. So this comment here about if you just give the name of the script with no arguments whatsoever, it will automatically display helpful information. I think that's probably one of the nicest things you can do for your users, is just type the name of the script and I will tell you a quick intro about what the script is supposed to be doing and how you can use it. I think that's probably the minimum that you should be aiming for a command line interface. Also, yeah, what options are available? So on Linux, you can usually, for many programs, you can type man space, whatever the program is. So these programs here, cat, grep, ls, and du, these are all Linux built-ins, and you can type man and then the command, and it gives you pages and pages of excruciating detail about what's going on. That's probably not required. But I think for many of these, you can type like ls dash question mark or something like that, and it might tell you what options are available. Yeah, cool, okay. Seeing the version of the software, this is an excellent idea. So if you're going to try and tell somebody, I'm running Myriad, I want to figure out what version it is so that when I run a tutorial to help others, or if someone's complaining about a bug that they found, it's really good to be able to see what the version is available. Dumping a default configuration to a file, that is another excellent idea. So I've seen that with SWarp and SExtractor and other programs in that same kind of package. This is a piece of software that relies heavily on a very extensive configuration file to be able to do all of the work that's required. And just having this option to create a default configuration file and dump it into the current directory is a really nice user-friendly one. It means that people don't have to recreate things from scratch. So excellent. These are all great responses. Let's have a look. So I think I covered a couple of these things, although that dumping the default thing to the default configuration was one that I had forgotten about. The other thing that might be good, so there's these two at the bottom here, which is saying to write your output to standard out and write your warnings, errors, debug messages to standard error. Now, somebody who's interacting with the terminal will just see the same text scrolling by. But if you're using a little bit of Linux Kung Fu, you can actually direct standard out to one file and all of the standard error can go somewhere else. Sometimes that just goes to dev null. But if your output goes to standard out, that means that you can do things like just pipe the output of your file into, pipe the output of your program into another program. So before, when people said here about cat, grep, ls, and du, you've probably seen, or maybe you've done this yourself, where you can say, you know, ls, the current directory, and then you pipe that to grep, and you grep for files that end in .py, just to see what all of the Python files are. I mean, obviously you can do ls star.py, or you can cat a file and grep for certain words that are within that file.
Well, one of my favorite is you can go ls and you pipe it into word count with -l, and it tells you how many lines, so you can count how many files there are. I like that one.
Excellent. Did everybody hear that?
I'll put it in the chat as well.
Okay. So yeah, Nick was just had another really good example there. So yeah, writing your output to standard out means that you can pipe your output to other programs. having an option to accept standard in as an input instead of a file allows you to then use other programs to pipe things into your program. So I list these here because they're nice ideas. They're not always easy to implement. It depends on what type of software or program that you're writing. So for example, you wouldn't really want to pipe the output of your calibration to the terminal. You know, it'd be better if you save that to a measurement set or something like that. Okay, good. A graphical user interface can be really nice for people, but at least in my experience, it is way harder than you'll ever think it's going to be. And I have not yet got over the hump of finding the justification of the utility of a graphical user interface, given how difficult it is to implement. So unless your software is inherently a graphical thing, like you're trying to display animations and things like that, you're probably better off ignoring it. A command line interface is probably going to work for most people. Something that I have done before, instead of trying to, use all of these different graphical libraries to create a nice interface, sometimes it's easier just to make a web app, just to make like a web page that contains the logic of what you're doing. So for example, there's the, I forgot what it's called now. There's a website that you can go to and you just say, what's the age of the universe? And you get things like the look back time, the distance, the angular distance, all of these, luminosity distance, that sort of thing. I've forgotten the name of the person who... Cosmic Calculator, that's the one. Way back in my day, that was just a command line tool that you had to use. And you always forgot where you put it on your computer. And then somebody just said, oh, you know what, let's just make this a website. And now it's, extremely useful. So depending again on what you're doing, maybe a website will be better than a full graphical user interface. All right, so the next thing that you can do to polish your code is to do it with style. And when I say style, I mean something that's different from syntax. So every language has its own syntax about how you need to communicate with the interpreter or the compiler. But some languages give you a lot of flexibility in that syntax. And so style is about how you do things within that flexible framework. And the goal here is to make your code, the source code, as readable as possible. So some of the things that you should consider are naming conventions. So how do you name classes? How do you name functions and parameters and things like that? There are lots of options. There's a few here that I've given for the matrix multiply. I think the key for coding style is usually to be consistent. There isn't necessarily one right answer for what you should do, but so long as you're consistent within your project, it will make it easier for other people to understand. So, for example, if you use this camel case here for matrix multiply, if you use that camel case for classes and you use this sort of lowercase with underscores instead of spaces for functions, then people can have a look at the code and very quickly understand whether they're looking at something which is a class that's being instantiated or whether they're just calling a function just by looking at that sort of formatting there. Okay. Another thing, so depending on the language, you might have access to namespaces, which in Python would look like this. So you'd have the sign function being provided by many different modules. And it's a nice idea to be able to use those namespaces so that you can understand that when you're calling the sign function, you know whether this is coming from the NumPy library, whether it's coming from the built-in math library, or whether this is some custom thing that you've done yourself. Okay. So it's a little bit extra code, a few extra characters to type every time you're using the sign function, but at least it lets you understand where that function is being called from. And if there are problems, you know where to look for those problems. Another thing which is a nice idea is to use a linter to enforce your coding style. So I'll talk a little bit about linters in a minute, I think. But essentially a linter is a little bit like a, I guess it's a bit like a compiler in that it looks through your code and checks for correctness. But the linter actually doesn't do any compilation. It will do two things. It will firstly check that your syntax is correct, and then also check that you're following whatever particular style you have chosen. So for Python, there are lots of different linters out there. One of them is just called Black. And you can say, I would like to follow the PEP8 style guide, and it will go through and it will tell you you've forgotten to put a space on either side of this plus operator. You've got a comma here that doesn't have a space before it, or whatever happens to be the case. All of these things that are not actually affecting the running or the logical flow of your program, but have an impact on your ability to read and understand the program. That is what the style is all about. And that's what linters can help you with. And the other thing is to follow code idioms. So I guess one way to demonstrate this is that we have this piece of code here, which does a thing. It does it fairly well, I guess. But I would challenge anybody to figure out what the heck this piece of code actually does. So if you don't read Python, you won't get it. If you do read Python, you probably still won't get it, because this is a very obtuse piece of code. This is probably somebody who was trying to write, if you've ever heard of code golf before, as in writing the smallest number of characters to execute your code. This is probably the result of that. At the end of the day, it prints out these numbers. So you might be able to look at these numbers output and sort of reverse engineer what it's doing, which is finding prime numbers. But exactly how it does it is really, really unclear. And if there was a bug in here and it wasn't doing what it's supposed to do, it'd be really, really hard to debug. So I consider these sort of one-liner solutions as write only. You can write them, but you can't read them and then make any sense out of them. So what we could do is refactor that into what we see here, which does the same thing, okay? It produces the same output, and it follows the same logic as well, okay? In terms of speed and memory use, it's probably very much the same. But this piece of code here is much more readable. So for example, you know, firstly, where your square root function is coming from, because it came from the math function. You've got some names here that kind of give you some tips as to what's going on. So for example, we're creating a sieve. We're looking for numbers that are possibly multiples of other numbers. And then eventually we're looking for numbers, and then this thing here, which is a Boolean, which is prime. So this kind of gives us a clue that this is a prime number sieve. And if we just Google for prime number sieve, we'll get this algorithm. So this is one example of how just writing the code in a sort of more verbose, clear way can help you understand what's going on. Of course, I would probably also come through here and write some comments to say, you know, I took this algorithm from Stack Overflow or something like that and put a link into it. That would also help out. Yes, okay, I think that's all I wanted to say about that. There's another example here, which is kind of the inverse. So this is a very famous piece of code which computes the fast inverse square root. So we know what it does, but as to how this thing works, there are, well, read the Wikipedia article as to how this works. This is a singular piece of genius as to how this can very quickly give you the fast inverse square root. But the actual implementation here, particularly this random string of garbage, just makes this like impenetrable for anybody to understand. And this is effectively the code as it stood. The person who wrote this code didn't feel the need to explain themselves. So it took a fair while for people to understand how this was working. no doubt it took them a very long time to debug this, if there was ever an error. Okay, so yeah, as I said before, a linter can be very useful. This is sort of like an automatic checking of syntax, but also style. So even if you have compiled languages, they implement a linter as part of the compile stage. So if you've ever compiled something in C and you get these warnings that come out that say, you know, variable X was declared, but you never used it, that's a form of linting, which is saying that you've done things that you didn't need to do. And so you could probably, for clarity's sake, go back and not declare that variable, just comment that line out. Or maybe it's a hint that you should have used it and you didn't, and so maybe your algorithm's going to be a bit wrong. You know, a lot of people just turn off the warnings for their compilers because they don't care about them, but they're actually a good idea to leave on and to investigate. I found this nice GitHub page that has a bunch of awesome linters for heaps and heaps of different languages. Your language will be on there with instructions about how to use the linter. Yeah, and again, for Python, we usually follow this PEP8, which is essentially a protocol, I guess they call it, about how you should write Python code. The interpreter will accept just about anything, but if you follow these suggestions about how many spaces for indentation, how and where to do your imports and define classes and functions and stuff like that. If you follow all of these, then it means that when you open up somebody else's code, it will be structured in a way that's very similar to yours. So in some ways, this is taking your project structure from the directory file level and applying this also to within a file. How do we structure writing our software such that it's easy for people to understand and to follow. Yep, so 2 unsolved problems in computing: cache invalidation, naming things, and off by 1 errors. Naming things seems like a really silly thing to mention, but the number of times that I have read through code where they've just got I as variables, and it makes it extremely difficult to understand what the hell is going on. So naming things is important. You should spend some time and effort thinking about the names that you choose. It's probably a good idea that classes should be nouns because they're things. So classes and variables should be nouns. Maybe you should use verbs for functions. I tend to use singular nouns for variables that are just singletons, and variables that are lists or arrays, I usually use a plural because it just kind of gives me a bit of a clue as to what that variable is doing. Yeah, be verbose, but obviously if you've got a variable name that's 50 characters long, that's going to be tedious for you. Some examples here would be to use underscores for functions, camel case for classes, and all caps with spaces for static variables. Now, in some languages that have strict typing, or I guess it's strict typing, so in C and Fortran, for example, you can define variables that are not allowed to change, so static variables. You can't do that in Python, but there's nothing from stopping you defining something that shouldn't change and just using it as all caps. That's usually a good hint to other people that, you know, they shouldn't mess with this variable, otherwise you're going to break things. So naming conventions can help you increase the readability of your code. The other thing that I should mention, this is actually saying the same thing. The other thing that I should mention is that naming is important. Please don't choose silly or not safe for work names for any of your software. I think many people have experienced the S extractor software, and having to type sex on the command line all the time is either funny or tedious, depending on how old you are. And there are other software out there that have even worse names that I won't repeat, which I refuse to use because of their name. So yeah, consider the names that you choose. Usually a good idea, just kind of Google the word before you use it, in case it's some kind of hilariously wrong thing that you were innocently going to name your software. Yeah. All right. So the next thing is about coding idioms. And what I would like from you firstly is an example of an idiom. And I don't mean a software idiom, I mean like a language idiom. This is where I find it's the most entertaining for me, because I actually quite like idioms. So if you don't know what an idiom is, it's essentially a usually fairly nonsensical phrase that we give a very particular meaning. Okay. So let's see what would be now I'm blanking on some of my favorite idioms. So if you've ever heard somebody say that that person is a six-pack short of a carton, that is an idiom to say that they're actually not that bright. Okay. So I'll give you a bit of time to come up with these. Feel free to do English translations of idioms from other languages. Stars in their eyes. Ah, that's a great one. Yep. So yeah, stars in their eyes is a great example. Obviously, people don't have actual stars in their eyes, but we know what it means. You know, people who have got big hopes, big dreams. Day late and $1 short. Piece of cake. Yeah, there we go. So by itself, piece of cake is a thing, but we use it to indicate something that is easy, because you know, making cakes is easy, I guess. A few sandwiches short of a picnic. Good, good, good. All righty. The robe doesn't make the monk. That's a good one. Haven't heard that one before. All righty. I'm doing okay for time. Something must kill a man. Oh, interesting. What is this one supposed to mean? Because something must kill a man has, well, a particular meaning to me, but I'm assuming that it's not the meaning, the literal meaning.
Yeah, it's like YOLO. Like, let's have cake.
Yeah,
Something will
okay.
kill a man.
Oh, I see. Yeah, something must kill a man. As in, yeah, you have to die of something, that kind of thing. Okay,
Yeah.
I got that. That's cool. Apple doesn't fall far from the tree. Great. Yeah, so that's another example of a thing which is like, well, yeah, obviously, because trees are not that big, taking the literal meaning. Okay, good, good, good. All right, so so essentially the idiom is something where we're trying to express an idea, and we do that using a particular set of words that we've given meaning, and maybe it takes you a long time to figure out what that meaning is the first time, but you hear it so often that you instantly understand what it is. So that's the same thing when we're writing code. For any piece of software, there's usually lots of different ways of doing a particular task. And you shouldn't try and be, you know, unique and special and reinvent things every single time if you don't need to. So for doing a lot of basic tasks, it's a good idea to follow idioms, to follow these common ways of doing a common task. One of the reasons is that you're not having to reinvent it every time. And so you're essentially just saying, yeah, I know how to open files. I type this, it's done. I'm not really going to think that hard about it. Of course, the idioms can be different for different bits of software. So for Python, C, and R, I found these sort of guides online. The guide for R I liked in particular because it's called archaeology. It seems like the people who write R, they love their sort of pirate parlance. Not sure why, but anyway, it seemed to be a cool group. Yeah, in Python, we're obsessed with snakes. So for example, in Python, here are two ways of opening and reading a file. So we can define the file name. And the first one here, I said this works, where you just open the file, you then read it, and then you close the file. This will work. There are lots of sort of corner cases as to where this would go wrong. But what we would say the idiomatic way is we use this technique down the bottom here, where we use the with, what's the word? It's not an operator. I forgot what they call these things now. Anyway, the with syntax, I guess. So this idiomatic way here means that when you break out of this indentation block, Python will automatically close the file and figure everything out for you. So in the top way here, you can open a file and forget to close it. And if you're only opening one file, it doesn't matter, but you can end up with heaps and heaps of files being opened and locked for other users, those sorts of problems. So if we use this idiomatic way, then it avoids a lot of problems that we might never care about, but it would avoid problems that could come up in the future. It also means that other people can just look at this and go, yeah, I know what that's doing. It's just opening a file and reading it. I can move on with my life. Yeah, so have a look through here. Search for idiomatic coding for your particular language. And there's usually, I mean, a lot of the idioms you're probably already following, but there's often a couple of good ones in there. So for example, this with open file is one that I learned not too long ago, and I try to use all the time now. So these are just sort of some of the ways to improve your software skills. Something else that can make a really big difference to how well people perceive your code to be polished is documentation. I like to think about documentation as a love letter that you write to your future self. So sort of reminding yourself how you've done all of these things. So when you're doing your research, you have a notebook where you record what you're doing and why you're doing it and little bits of stuff here and there. And in the future, when you come back to write your paper about the work that you've done, you will refer back to your notebook to remember what's been going on. You should do similar things for your software. And you can either write it in your notebook, or usually you can write it as part of the documentation about how you did things and why you did things. So there's a bunch of different places where you can do this documentation. You could just put it all into the README file in your repository. Usually this is where you'd want to give a general overview. You could create a wiki or a web page that gives super detailed, this is how everything works. Here's some questions that people have asked. Here's some examples. I've seen some bits of software, they just provide a PDF. When you install the software, there's a PDF or like an HTML directory that you can read through. You can host your documentation on readthedocs.io for free. This is really easy if your software is in a GitHub or GitLab or Bitbucket repo. You can link those two together quite well. The important thing, though, is that you update your documentation when you update your code, because documentation that is out of date is extremely frustrating for people and will sometimes turn people away from using your software, or they'll just bombard you with questions via email. It's a good idea to have a frequently asked questions section. So for some of my software projects, every time somebody sends me a question via email, I just copy that question into my FAQ and then answer the question there. And then I just point them towards the web address to say, there you go, question's answered. And the good thing about that is that you usually don't get the same question asked of you multiple times. So it saves you time, and it also saves the user's time as well. There's different types of documentation depending on your audience. So for the users, you want something that describes how you, or the intended use of the software. The users don't need to know how things work. They just need to know that things will work if they use the software in the right way. So they don't need to know all the details about the particular algorithms and program flow that's in place. Whereas developers are maybe people who are going to reuse the logic in your code, or maybe they're going to dive in and try and fix bugs or add features. And so for them, you do need to explain how things work. And two good places are, one, to have comments within the source code about the choices that you've made and why, and maybe a separate document that outlines the design choices and intent. So you might have a document that describes why you've used particular algorithms or the particular implementation of those algorithms. And then for both, either the users or developers, it's good to have a list of the modules or classes or functions that you've created that they might want to make use of. And so if you put all of this with their call signatures and parameters and stuff, if you put all of that together, that's essentially an API that people can look at. If you go to the learn.astropy.org, they have a great example of how to use the AstroPy Python module. They present this as a bunch of tutorials, some of which are Jupyter notebooks that allow you to just download them and use them directly. So this is a really good way of both documenting your code, but also getting people in the front door, over that barrier for entry, so that they can start using your code. Example data is very handy. Often one of the first things that people struggle with is just having data that's in the right format for your piece of software. And I said here, use your test data is often a good place to do those examples. All right, so testing is another way that you can polish your code. This is maybe not immediately obvious to your end users, except for the fact that hopefully if you do your testing properly, they will experience less bugs, less problems. Testing is about the only thing that people write less than documentation. So there are many, many projects that I've seen that have no documentation and no test code. And I mean, mostly that's fine because not every single project needs it. If your project is just a very small thing that is, your script is meant to work with one particular data type and do one particular thing, just running the code and having it work is test enough. But as your code base gets larger, as your software package becomes more, I guess it has a greater scope, then writing documentation for people and writing tests for all of that can be extremely important. So the documentation and tests, to me, these are highly related things because the documentation is telling you what the software should do, and then the tests are confirming that that's what it actually does, okay? So these documentations and tests are easier to write if you do them at the same time and as part of your development process. Coming back to a project weeks after you've finished it and trying to write the documentation and the test for it is a real nightmare, and probably why most people don't do it. So ideally, you would sort of write your function definition and a basic doc string, which is essentially to say, this is what I think the function should look like in terms of how you call the function. And then I'm going to write a short description of what the function should do and what it should return to the user. And then you write the contents of the function, so actually make it do the thing. And then write a test that convinces you that the function does what your documentation says that it should do. And then you should update all three, so the code, the documentation, and the tests until they all agree, okay? So sometimes when people have a bug report, somebody sends me a bug report and says, the documentation says the code should do X, but it doesn't. Sometimes, I mean, it's a little bit cheeky, but sometimes I just change the documentation and say, yeah, I never intended it to do that. So I'm going to change the documentation. And now all three things agree. So we're all good. Maybe for the end user, they're not so happy because it doesn't do the thing they wanted it to do. But at least at least it's consistent, and at least people can understand, sort of like not chase code that's going to not work for them. So I think that's important to think about those three things: the code, the documentation, and the tests as needing to be not only related, but to be consistent with each other. So the question that people always ask is, what do I even test? At the moment, when you've written a piece of code, you have done something to convince yourself that it works. It could just be, I ran the code from the command line and it produced an output file, which I opened and looked at, and it looked fine. That can be your testing procedure, okay? And if that's what you do, just sort of write a note to yourself, you know, PS, every time I make changes to my code, make sure that this is still the case. That's one way to generate your tests. And another way to generate your tests is to, every time you make a mistake, every time something goes wrong, write a test case that will check for that bug and complain when it comes back again, okay? So I like to think that making mistakes doesn't make you a bad person. That's just part of living and learning. But making the same mistake over and over again does. So maybe you're not a bad person, but you know, it's frustrating to continuously make the same mistake over and over again. And so a bit of automated testing can help you avoid this. So automated testing, firstly, you need to create the tests. So in general, a test is you defining some behavior and output that is expected for a given input. So some examples here would be, if I gave an input of -1, then my code needs to raise an exception because that's not a valid input, okay? If I gave an input of 2, then it should return the value 4. If my input was a string, hello.txt, and the number 13, then it should return the 13th line of the file, hello.txt. These are just some really basic ideas about what you would expect the input and what behavior or output you would expect. Once you've got those expectations in place, then you can start to write code that will check that this is true. So how do you do that? It depends on your language, exactly how you write those tests. It also depends a little bit on the testing environment or test harness that you're using. So in Python, I would recommend PyTest as sort of like the entry level, easy to write, easy to use testing environment. In C, I don't have any recommendations. There are just so many available, and the people that I've talked to have all recommended different things. So I don't have any good advice there. For R, there's a package called testbat, which I think works similarly to the Python PyTest, which does this sort of automatic discovery of all of your test cases, and then it runs them and then it reports things to you. So for example, in Python, I have written, usually I wouldn't do this all in the one file, but for this example I did. I've written a script, a function, which is called calculate, and it takes these two parameters, I and j. It does something, okay, it does nothing, it just sleeps for a little bit, and then returns a value. And I have said that my expected output is 0 if your input is 0, 0, okay? So in my new function called test_calculate, I say, this is my expected output, which I just call correct. The answer is what I actually get when I run the function. And then I just say, if the answer is not correct, then I raise this exception, okay? And if I've written my test in this way, then PyTest will read through all of my Python files. It will find all of the functions that start with test_, and it will run those functions. And if those functions return nothing, it assumes that the test passed. And if the functions raise an exception, it will catch that exception. It will deal with it. It won't crash. And then it will record it for later. So what will happen is when I run this using PyTest, this is actually for not that piece of code, for a different one. So PyTest, sorry, will run all of these functions that have names like test underscore, and it will collect all the warnings and failures, and then we'll show you a summary. So this is me running PyTest on this test underscore mimus file. And you can see each of these little green dots here is one of the 3 tests that I had defined, and they all passed because they're green dots. If they fail, you get a big capital red F instead. And once it's done this, it says, there we go, 100% tested. And then we get a warning summary. So this is just every now and then these things emit warnings, and we can kind of ignore this because it's a warning. Everybody ignores warnings. But we get this little summary at the bottom here that says 3 tests passed. There was 1 warning, and it took 0.098 seconds to run the tests. And so just by writing something as simple as this, calculate and then test calculate, you can have PyTest do all of this nice work for you. Okay. Yeah. And then essentially you develop some code, you fix a bug, you do some new features or whatever. And before you go and send that code to other people, you just run all of your tests to make sure that they pass. And that gives you the confidence that you haven't introduced any new bugs, or rather you haven't reintroduced old bugs. Okay. An important thing to note about testing though is this concept of coverage. And a coverage report will tell you each line which parts of your code were run during the testing. So PyTest allows you to create a coverage report. There are lots of different, again, depending on the languages and depending on the modules that you're using, different ways of creating this code coverage. But the idea is that you can't catch bugs in code if you don't test that code. So if there's a line of code that's broken and that code never runs during your tests, you won't know that it's broken, okay? So usually people aim for getting a fairly high percentage of their code being run during the tests. Some of the codes that I have, the tests that I've written, like for Mimus, is doing simple things like import the module to make sure it doesn't break. And that's like, you know, the 0 effort type of test. Other ones are more difficult because you have to set up a lot of complicated data types. You might have to set up a service that's running on your computer for it to connect to. And so sometimes writing the tests and running the tests can be really difficult. So just kind of think to yourself how much effort you want to put into the testing, or how much confidence do you want to have that the code will work. Having code with no tests is fine, so long as you tell people, this is not tested code. If it breaks, beware. So the other thing that I'd say is sort of some final thoughts that are not part of the original outline, was to leave a pretty corpse. So if your program needs to end early, it needs to fail or exit or crash, do it with a descriptive reason. Do it nicely, so that people can understand why it broke and what went wrong. I'm sure everybody's had the experience where they've tried to run something and then it just says seg fault, and then that's it. Gives you absolutely no idea about why or where the code has broken. You can make guesses, but often there's nothing you can do about it. So the other thing you can do to polish your code is to make it clear to people why everything broke, okay? And if it's the case of you don't have enough memory, or you know, the file doesn't exist or something like that, at least people can understand and, I don't know, get a new computer or run it elsewhere or fix their files or something like that. This is all part of sort of being useful, giving useful feedback. And the last thing you can do for making your code polished is to make it accessible. And accessible, there's a few different ways that it can be accessible. So in terms of usage, you can license your code so that people are allowed to use and reuse your code. You can use open source tools So using languages like Python and C, where they're free to use, as opposed to things like IDL or MATLAB or something where you need licenses, that can make it more accessible to people. You can use language for non-experts or non-programmers to help people understand what it is that you're doing. As we mentioned before, avoid not safe for work language, be professional, but also be findable. Make it so that people can actually literally access your code from the internet without having to send you an email and asking a zip file or something like that. So putting your code onto GitHub or Zenodo or something like that can make your code more accessible. And that, again, is another sort of form of polishing. All right, so I'll leave this summary here. Does anybody have any questions or comments about polishing before we move on to the final two components?
I guess I could ask a question. In industry, it seems like you're allowed the time to polish. In academia, it feels like you're not allowed the time to polish, even though it might help you in the future. So what are some ways to actually make it happen or be more efficient at it, or at least get some of it?
Yeah, okay, that's a really good question, because it's a problem that a lot of people face. So yeah, the common problem being you've spent time writing your code and it works, and then as soon as it works, everybody who, like maybe your supervisor or your colleagues, have said, thank you, good, move on to something else, please. We don't want you spending more time on something that already works, because in their minds, that's a waste of time. Why would you continue to work on something that's already working? And I think this is born out of two things. One, academics being time poor, and two, people not having an understanding that this good coding style, this good project structure will in the future save you time. I've seen many projects starting from people spending a lot of time reinventing stuff that other people have done. And that is a really big waste of time. And the reason they've reinvented it is because they didn't know that somebody else had already done this thing. So the other person's work wasn't being advertised and it wasn't accessible. So people thought that it didn't exist, and then went and recreated it for themselves. I guess there's a couple of ways to combat that. One way is to, I guess, get people to have a better understanding about the importance of software in research, and about the importance of having reliable, reproducible software, which is why I was so happy to see people coming to this presentation saying that I don't code, but I want to understand what the issues are for people who do code. So that's sort of one step. The other step is sort of the next two things that we're going to talk about in terms of publishing and citing code. Because if you can say to people, yes, the code works, but if I polish this code and I make it available to others, I can then publish that code and I can get citations for that. And academics more easily understand, oh yeah, publications and citations, that's worth spending time on. So this isn't like, not all projects can get to that stage, but if you can find a way that the effort that you spend on polishing your code leads to publication and then citation, it becomes a bit easier to convince people to let you spend that time, or at least not harass you for spending that time.
Thanks.
All right. Well, let's move on to some of those other topics. So we already did our break. So the next topic is publishing. So my first question to you is, why would you want to publish your code? What's in it for you? Why would you want to go through this process? Fame and fortune. Fame, probably. I'm not sure that many astronomers got rich from writing code, but I get what you mean. Helpful if you want to switch to industry career in the future. Yes, this is a very valid reason for wanting to publish code. So whether publishing means putting it on GitHub or writing a paper about it, you've essentially put your skills out there for others to see. So yeah, if you want to switch to an industry career, it can be useful to have your code published. Another form of advertising is another great way. So this can be a way of advertising your skills even within academia. So despite the fact that software development in academia is not as well respected as it should be, in my opinion, people do at least understand that, you know, when you're applying for a job and you can say, hey, I've written all these papers, I've led all these collaborations, I've done this great stuff. Also, I've written this software. People who are hiring will often say, oh, good, this is somebody who can do the work that we need. So yeah, another form of advertising. Reusability is really good. If you can save other people time by publishing your work, that is a service that you're doing to the community. Hopefully, if we normalize this reusability, then it will save you time as well, because you will find somebody else's published code that you can use as a starting point for your own work. Yeah, standard data analysis approaches. So again, normalizing the analysis, imposing my view of data analysis approaches on everyone else. Yes, I mean, obviously, if you think you're right, you want to try and get everybody on your side. And yeah, publishing is the software is a great way of doing that. Sometimes I like to think about software as like the most pure form of your methods section of your paper. A lot of the time I see papers with a methods section that's about, 3 paragraphs that says standard processing techniques, and then they move on. And that doesn't allow you to understand what they did or reproduce it. Whereas if they make software available, if they just say, we use this software with these commands, that's usually enough to understand what they've done. Helps raise your own profiles and yeah, avoid duplication. Excellent. Proof of skills for future jobs. Great, great, great. So no one has to go through my pain again. Oh, that is very true. Yep, help with research and reproducibility. Excellent. Okay, so great responses. I love all of them. I of course put some of my own things here, and I think everybody's pretty much hit on these. Yep, there's nothing extra for me to be able to say here, so we'll get on with that. So I think that people understand that publishing is something you want to do. One of my questions, though, is what does publish even mean? And there's actually lots of different things that publishing means. So some, but potentially not all of, making your software available, making it findable, making it understandable, and making it usable. These are all things that you should consider when publishing your code. You don't have to do all of these things. Obviously, the more that you do, the better. If you publish code, you do not have to do any of the following. You don't have to support bugs or feature requests, okay? You don't have to support other people's data or compiler or operating systems or whatever. You don't even have to have good code. And if you don't want to, you don't have to respond to any kind of emails from anyone ever. Okay, so these are things that people have said to me are barriers for them publishing code. They feel like they have an obligation to do some of these things. And I'm here to tell you that you don't have to, okay? If you have the time and the inclination, this would be nice, but it's not essential, okay? So essentially what I'm saying is the bar for publishing code is very low. Throw it on GitHub, put a README there, and say, please don't bug me because I won't answer your emails. Done. You have published your code. It's available to others. You've made it clear the level of support that you're going to provide. Okay. If you look at a lot of GitHub repos, they'll have notes about how you can contribute to their code. And some of them just say, I'm putting the code here for other people to use. I'm leaving academia. I'm not supporting the code. Have fun, bye-bye. And you know what? That's actually useful to people because they can use it. They know not to email, that they're not going to get a response. The expectations have been set. So I would argue that if your code is good enough to use, it's good enough to publish. But even more, if you've used it, you should publish it. So if you have a paper and you said, oh, we wrote some code to do X, Y, Z, you should publish that code. You should put it on a GitHub repo and just link to it in your paper so that other people can see what you're doing. In my experience, almost nobody ever reads or looks at your code when they're refereeing your paper because the referees are told to focus on the science. But sometimes you will get people who come back and say, hey, I used your piece of code. It was really useful. Should I just cite that paper where you mentioned it? And the answer is, yeah, sure, cite that paper. You get yourself some extra credit there. If you do want to publish code in a journal, if you want to write a paper about your code, there are a couple of options. So you can go to what I would just say regular journals, which are ones that focus on the science applications. So PASA, monthly notices, AppJ, etc. They're all places where I've seen people publish a science result, but also with an extensive amount of description of the new code that they had written in order to get to that science result. Sadly, Science and Nature, they don't publish code. That's just a bias that we'll have to live with. But there are also boutique journals which focus on the code itself. And when I say focus on the code itself, I mean that you don't need to have any science results to be able to publish there. And particularly journals like JOSS, the Journal of Open Source Software, their review process is to read and understand the code. So the people who are reviewing your publication are actually reviewing your code as well. They're going through code review. Astronomy and computing, there's a little bit of focus on that, but it's mostly about the paper that you submit. But yeah, so they're depending on like how much effort you want to go to, which I guess is a measure of how much benefit you think you might get. There are different journals that you can publish your code. The advantage of publishing in a journal is that academia in general understands what a journal publication is and how to cite it. And so that's sort of an easy way to get your code out there. Apart from writing papers, you want to put your code on repositories. So GitHub, GitLab, places like that are all good to share, but also good to do the development and documentation of your code all in one. The Astronomer's Source Code Library.net, ASCL.net, is a place where you don't put your code, but you put a short description of your code. And it generates a DOI and it gets indexed by ADACS, so people can cite that. Similarly for Zenodo, Zenodo will let you put even just data. If you want to publish your data as well, you can put it on Zenodo, and that will get a DOI that people can cite. If you're using Python or R, you can have your software installed to a sort of a central repository. So the Python package index is one of the most easily accessible places for people to download your software from. And for R, there is the CRAN, CRAN repository, which makes it easy for people to, again, download and install. For many long and varied reasons, C doesn't have such a centralized repo. But the above are also good places for people to be able to find your code. And that's, again, sort of part of what this publishing is about, allowing people to find your code. Also recommend it. If you publish something, tell people that it's there. Be shameless in your advertising. Figure out where your users are and tell them that you've got some cool code and that it might be useful. Do that at conferences with talks or posters. There are even some conferences which are specifically for software. So the Astronomical Data Analysis Software Systems, ADAS, is a really, really interesting conference series that you can go to. You don't need to be an amazing expert to be able to sign up and go. You can just turn up to listen and hear what everybody's doing in software, in astronomy, data and software. And this year, at least, ADAS is 100% online, so it's sort of cheap and easy to access. So, question for you, we'll have to make this quick. What software do you use as part of your research? Whether it's a software package, whether it's a module that you use as part of your programming, maybe it's a script that you inherited from somebody. Think about the types of software that you use as part of your research. They don't have to be published. This could just be something that your friend sent you in an email. Let's have a look and see what people are saying. NumPy, SciPy, Matplotlib, Pandas, AstroPy. Yes, excellent. Okay, these are all great Python modules that are extremely commonly used. The Wortinger pack, DD-Facet and KillMS. Okay, great. I think that's all in CASA. HEA soft, yes. Okay, so these are all excellent examples. Somebody's saying, yeah, a lot of self-made code. Okay, that's also a good example. So these are all sort of data manipulation and I guess in some level visualization tools. But what about things like, I'm not sure what MESA is. That's just my own ignorance. What about things like visualization tools, like maybe using Aladdin or DS9 or something like that? There are also things that people commonly use, or maybe TopCat. Okay, yeah, simulation tool. Okay, great. Yeah, so these are all pieces of software that somebody has sat down, taken the time to write, and then publish. Okay, and so QFIT's view, yeah, another good example. That leads us to the next part, which is citation. Okay, so all of those things that you mentioned are pieces of software that you use in your research. And I would hope, but I know it's probably not true, is that in all of the papers that you write, you give credit to the authors of those pieces of software by citing their code. Okay. And the reason I say I suspect it's not true is not because I'm making a judgment of you people who are here, is just that in general, when I look at astronomy papers, they have very little mention of the actual software that was used to do the work. They might say, oh, we use Myriad, but often would forget to give a citation to the paper that describes it, or a link to the repository that has that code. So all of the things that people mentioned here, next time you publish, please make an effort to go and find the people who wrote this software, how they want to be credited, okay? So part of citing code is about giving credit, but it's also about getting credit, okay? So on the giving credit side, you should ask people how they want to be cited, how they want to get credit. That maybe take a long time because they don't answer emails or whatever. If there's a code repository, you can have a look at that. Sometimes people put in their README file, this is how I want you to credit me, just like link to, like, cite this paper or link to this repository or something. You could email them. But whatever you do, please try to be inclusive of the credit that you give. A lot of people ask the question, could I have done this work without such and such software? And often the answer is yes, disingenuinely. People say, oh, I could have written this myself, but I couldn't be bothered. The question you should ask is, did you use whatever software at any point in this project? And if the answer is yes to that, then legitimately you should be giving credit to people. And the way that you can give credit or reward contributions is acknowledgement. So the acknowledgement section of your paper, you can cite things. So in the main body of the paper, you can give citation, probably in your methods section, or if the work has really been kind of integral to your project, you might consider including the software authors as co-authors on your paper. Obviously, published software is easier to cite than anything else. And yeah, the acknowledgement section is a great place to just kind of bundle all of the software citations that you want to add in that kind of didn't really naturally fall into the rest of the paper. And actually, I'm repeating myself, so I'm going to skip that. So here's an example. This is a paper that I wrote a while ago, and it could have been even more inclusive than what I've got here. But the acknowledgement section here, I started with the explicit software usage. So I started with the AstroPi collaboration. So AstroPi, they have a paper that they would like you to cite, 2013. There's another one in 2018, I think, which was after I published this paper. NumPy and SciPy both have citable references. And this LMFit module that I was using also had a citation. So these are the Python modules that I was using as part of this Aegean paper. I also used DS9 and TopCat and Aladdin as part of the visualization to sort of verify that what I was doing was correct and to visualize the outputs of my software. So it's appropriate that I gave them credit as well. And you'll note here that for DS9, I've just given a link to their website. One, because they don't have a paper, but two, that's what they asked. On the DS9 website, they say, please link to this website if you use the paper. So I did that. And then, of course, other contributions. So here we have a bunch of people that were contributing to the paper. But these two that I've underlined here are, as far as to me, these are random GitHub users who looked at my code, found a bug, fixed the bug, and then sent me a pull request to fix that. So this Sharky and Alexan, whatever. I don't know these people. I've never met them. I don't know their real names, but they contributed things on GitHub. So I've chucked them in the acknowledgement here. So there's lots of different ways to acknowledge people for the work that they've done. And this is something that you should do. And that feeds into the inverse of how should you get credit, okay? I'm not going to bother with licenses for now. So I'd encourage you to normalize good behavior by citing everything that you can. When you are a referee of a paper, you have the most influence on this behavior. So encourage people to have longer acknowledgement sections and to cite the code that they've used. I mean, of course, if it's your code, you want them to cite it, but even if it's not your code, encourage people to cite code more often. That will give more support to people who write code, allow them to continue to write more and better code in the future. So we can turn all of that around and talk about how you get credit. And I would say, whether you've published your code or not, like whether you've published it in a journal or whether you've just put it on GitHub or something, tell people how you would like to get credit. So if you want a little section in the acknowledgements of a paper, provide some example text. So if you use Chandra or Swift or I don't know, the VLT, a lot of these instruments have, as part of their application process, they'll say, when you get awarded time, you need to put this in your acknowledgement section. You can put the same sort of conditions on the use of your software. And I've never had somebody not use software because they didn't want to add an extra sentence to their acknowledgements. Okay, people are typically very happy to do that. You can ask people to cite a particular publication, or just to have a link to a web address about where the code is so that others can help can find it as well. You can ask for co-authorship. It's pretty hard to get people to add you to a paper, particularly if you didn't like sit in the office next to them helping them. But feel free to ask. Yeah, you can ask for money too. Probably not going to get it, but you can ask. So yeah, getting credit is more about sort of having your code out there, having it available for others, but telling people how you want to get credit and making it clear to them that they're benefiting from your work and that you should get a little bit of something in return in terms of a citation. This is exactly the same contract that we engage in when we read other people's papers and then we cite their papers. Okay, it's the same type of credit sharing that we're looking for. We just want to normalize this for software developers. And so calling back to an earlier slide where we talked about a command line interface, something really nice that I've seen people do and that I've copied now is that if I have like a paper that I have published relating to that piece of software, or if I just want to say link to this website or something, I add a -- cite option to my script that will just print out BibTeX of how to cite that particular piece of code. And that makes it really easy for people. They don't have to go hunting through websites or anything like that. They can go, oh yeah, copy BibTeX in the thing, cite done, took me 2 minutes. I didn't have to think too hard about it. So this is an example of what I've done for one of my software projects. So I put this onto GitHub, which makes it easier to find. I added a license so that people can reuse my work. Some institutes don't allow their researchers to work with unlicensed software. And so simply putting a license on it just increases your potential audience. And then here I've got a section that just says, if you use this, please give credit by citing, ideally both, but maybe only one of these papers. So this is sort of, people don't send me emails anymore asking about this. People just cite the paper because it's very easy for them to do so. And this is what I was talking about with the -- cite. So if you run the Aegean program and say -- cite, there's a bunch of BibTeX here that people can just copy paste, put it into their publication, and everything is nice and easy for them. So summary is that there's multiple forms of research output, not just papers. We also have lots of other research outputs, which include data, which include software. There are, I guess, creative works as well, potentially not so much in astronomy, but that's also another form of research output. And software among them needs to be, deserves to be credited, just like all the rest of them. So cite the software that you use, publish your software, and hopefully others will be just as generous and they will give you the credit that you deserve for the hard work that you've put in, allowing you to get those grants or jobs or whatever it is that you're looking for in the future. And I think that is my last slide. So I will open up to more questions now. If you want to put some responses in here about essentially what's your highlight for today, please do that. But yes, otherwise, question time. Okay. I'm just trying to find the chat. I've lost it somewhere. Here it is. Okay. Oh yes, as Duncan mentions, self-citations. Yeah. Yeah, if you've published a piece of code and then you use it, you'll probably use your code a lot during your career. And every time you use it, it's legitimate to cite it. And so yes, self-citations, you get a lot of work out of that.
There were some hands up. I don't know if people still want to ask questions.
Okay, I'm just scrolling back through the chat now to see what people have been going, which is excellent. Oh, okay, yeah, there's the joint publication with the AAS and JOS. Oh, that's a really good idea. You put the science in one place and your software in another place. Good idea. Yeah, private. You can make your repositories private on GitHub, so you can put everything there, work on it until you're happy, and then press the public button, which is essentially a form of publishing. All right. Well, I'm glad that people found that useful. See what the response is. Okay, great. Cool. All right, well, thank you, folks. If you have more questions, feel free to hang around and ask them. Otherwise, thank you for your engagement, and maybe we'll see you in person at a conference soon.
Thank you so much, Paul. Thanks, Nick.